All right, grade 10s, welcome to our first virtual lesson for Math 10C. It's very different trying to teach a lesson with empty desks, but I'm going to do my best. All right, so we're just moving on to a new unit. The unit is linear relations and functions. Lots of classes and lots of textbooks will actually teach relations and functions first and then linear relations. I'm going to be teaching you linear functions first, and then in the next unit we'll talk about relations and functions and what is a function. Now, before we can get into working with linear functions, we have to go back and do a little bit of review of some junior high concepts to make sure that you've got a good handle on solving equations. So this lesson is primarily a review of stuff that you should have already learned previously and probably are already quite comfortable with. So first of all, I just want to go right back to the beginning in terms of what an equal sign means. When we're looking at an equation, equations means that we have an equal sign. So 4 plus 2 equals 6 is an equation. If I just had x plus 4, that's an expression. An expression does not have an equal sign. An equation has an equal sign. But when we look at what an equal sign actually means, it means that both sides have the same value. So if I were to look at x plus 2 equals 7 and I want to find out is 4 a solution, I can actually do a left side, right side verification. So left side, right side. The left side of the equation is x plus 2. The right side of the equation is 7. So I sub in 4. 4 plus 2 is 6. So 4 is not a solution to x plus 2 equals 7. All right, for the next step here, I'd like you to actually pause the video, write out or do these questions on your own, and then unpause the video and check your answers. So this is, again, just a review of things from the past. So again, pause your video, do the questions, and then come back for the answers. And welcome back. All right, let's go through the answers and take a look at what you've got. So -2 plus -3 is -5. -2 plus 3 is 1. -2 minus 3 is -5. So that's like you owe me $2, you borrowed another 3, now you owe me $5. -2 minus a -3. Remember, double negatives can become positive. So -2 plus 3 is 1. 2 minus 3 is -1. And 2 minus a -3 is like 2 plus 3, which is 5. It's important that you don't mix up your adding with your multiplying. I've seen sometimes people go -2 plus -3 and they go, oh, a negative and a negative is a positive. But it's not when we're adding. When we're adding, it's like owing $2 and now you added another $3 that you owe me, so you owe me $5. When we get into multiplying and dividing, that's when we have to remember our multiplication rules. So a negative times a negative is a positive, and a negative times a positive is a negative. So if the signs are the same, the answer is positive. If the signs are opposite, the answer is negative. That's for even, that's when we're just dealing with two numbers. So -4 times -5 is positive 20. -4 times 5 is -20. Now if I had another negative, let's say I went -1 times -4 times 5, then I'm going to have a positive 20 because an even number of negatives is going to give me a positive. 4 times -5 is -20. -10 divided by -2 is positive 5. -10 divided by 2 is -5. And 10 divided by -2 is -5. All right, let's take a look at some one-step problems. Sorry, I'm just going to try to move my screen a little bit. All right, so x plus 2 equals 5. If I want to solve x plus 2 equals 5, when I'm solving equations, I have to do BEDMAS backwards. Yep, that's Sam Deb. So when I'm solving equations, I want to work from right to left when I'm dealing with BEDMAS. So I want to add or subtract first, multiply or divide, then do exponents, and then do brackets. Now I'm going to give you a really strange analogy for a minute. Some people buy into it, some people don't. But let me give you an example of an equation. I've got x plus 2 equals 5. Solving an equation is really just like trying to find the answer to a puzzle. And it's trying to find the hidden treasure or the unknown treasure. And so we're going to look at algebra as if it's an onion. Bear with me. Here's our treasure, and it's buried in the center of an onion. And when they buried that treasure, they added a 2, and they got a 5. And so if I want to work backwards into solving the equation, I basically have to peel away the layers in the opposite way. So again, the onion analogy may not work for you, but the idea of peeling away layers and doing the opposite operation is what I want you to draw from this. So if I have x plus 2 equals 5, that's like I've got my onion, in the center is an x, I've added a layer of plus 2. If I want to get to the x, I have to take away the layer of positive 2, meaning in order to peel it away, I have to take away 2. And so I have a 5, and if I take away 2, I'm going to get x equals 3. Other people can look at this more as a balanced scale. So I've got x plus 2 equals 5. I need x by itself. The opposite operation of adding 2 is subtracting 2. And so I'm going to have x equals 3. So if I lost you for the onion piece, don't worry about it. We'll just go back to the balance scale. But for some people, that onion analogy has helped in the past. All right, so if I've got x plus 2 equals 5, the opposite of adding 2 is subtracting 2. So x equals 3. X minus 4 equals 7. The opposite of subtracting 4 is adding 4. So x equals 11. And 12 equals x minus a negative 3. Well, it's helpful to start by rewriting that. 12 equals x plus 3. And if I want x by itself, I'm going to have to subtract 3 from both sides. So x will equal 12 minus 3, which is 9. So at this point, you may choose to go to your assignment and do some practice questions for one-step equations, or just work through the video and leave your assignment questions for when you get to class. So let's look at some other one-step problems that involve multiplying and dividing. So if I have negative 2x equals 8, that means negative 2 times x equals 8. Notice the little time sign in the x probably doesn't work so well. You can also write it as negative 2 dot x equals 8, and you can write it as negative 2 in brackets x equals 8. All of these 4 examples represent negative 2 times x equals 8. So if I want to get x by itself, I have to do the opposite operation by dividing by negative 2, so x will equal negative 4. If I have 360 equals negative 18a, I'm going to divide by negative 18, and a equals negative 20. Now when I get to negative 20 equals negative 5/3 x, there's a couple different ways that you can look at this question, and I'm going to show you both. One is just to say, well, negative 5/3 is just a number, so I'm going to divide everything by negative 5/3. But be very careful. When you're doing this on your calculator, you need to make sure to use brackets. So if you're putting this on your calculator, you're going to go 20 divided by bracket, negative 5 divided by 3. Close your bracket, hit enter, and you'll get negative 12. If you don't use your brackets, what will happen is you're going to go 20 divided by negative 5 divided by 3, and your calculator is going to give you negative 4/3. Because what your calculator is doing at this point is it's going 20 divided by negative 5, getting that answer, and then dividing by 3, rather than going negative 5 over 3, finding that answer, and then going 20 divided by that number. So our answer is x equals negative 12. Now another way to do this question is to look at it as a two-step problem. So we could have 20 equals negative 5x divided by 3. then we're looking at these as separate operations. We're looking at the negative 5x being multiplied and then dividing by 3. So our first step is to get rid of the divided by 3. And so we're going to multiply by 3, which gives me 60 equals 5x. Then we'll divide by 5. And 60 divided by 5, sorry, I missed my negative. 60 divided by 5 divided by negative 5 is negative 12. Again, if we look at example 4, it's the same type of question. We can go negative 36 divided by negative 12 over 7. Again, you'd have to remember your brackets. So you would go 36 divided by, in bracket, negative 12 over 7 is negative 21. So y equals negative divided by negative. Y equals positive 21. So if you notice on the calculator, I missed a negative. So I can bring that answer forward and just insert a negative, and then I get the correct answer. So little typos like that, you just got to be aware of on your calculator. If I wanted to do this using a two-step problem, I could have negative 36 equals negative 12y over 7. Again, I'd be wanting to get rid of my divide sign. So I'm going to multiply both sides by 7. So negative 36 times 7 is negative 252 equals negative 12y. Divide by negative 12, and we get positive 21. So again, on the calculator, I had negative 36 times 7 was negative 252. And if I divide by negative 12, negative 12, I get 21. So again, when you're dealing with fractions, sometimes it's easier to turn it into a two-step problem. You can keep it as a one-step, but just be very careful about the brackets on your calculator. I would suggest at this point, maybe pause the video, try doing those on your calculator, make sure you're comfortable with the steps. All right, so we're going to move into two-step equations, and this is kind of where sometimes that onion analogy might help some students thinking about peeling away the layers. Eventually, what I'd like you to be able to do is look at an equation and know all of your steps before you actually start doing anything. So for example, I've got 3x minus 7 equals 8. We're going to be doing BEDMAS backwards, because in order to get to the variable, we have to work from the outside in, and that's why I talk about the onion. We're working from the outside to the inside. So the first thing we have to do is add or subtract. We're always doing the opposite operation. Then we're going to divide or multiply, and then work through the exponents in the brackets if we have them. So for 3x minus 7 equals 8, I need to get x by itself. The first thing I'm going to have to do is get rid of the 7. So I'm going to add 7. Then I need to get rid of the 3. Right now 3 is being multiplied. So I'm going to divide by 3, and that will give me my answer. So I know that my steps are add 7 and divide by 3, but it's still important until you're really comfortable with the math to actually do those operations. So I'm going to add 7 to both sides, and that's going to give me 3x equals 15. I need to get x by itself. Right now it's being multiplied by 3, so divide by 3, and I'm going to get x equals 5. At any point, feel free to write down the examples, practice them for yourself first, and then check them on the video. So I have here negative 33 equals negative 9a plus 3. The first thing is to get rid of the positive 3, because we're dealing with the adding and subtracting first. So negative 33 minus 3 is negative 36 equals negative a, because a positive 3 times a negative 3 is going to cancel out. We have negative 9 times a, so we're going to divide by negative 9. That's the opposite operation. And we're going to get 4 equals a. Be careful not to always write x's. If the question calls for a variable of a or y or n, make sure you're using those. All right, it seems I can't move my screen up, so I'm going to move this question up here. I've got 8 minus n equals 13. I need 8 by itself, and right now I have a positive n. So when there's a negative n, When there's no sign in front of the number, that means it's positive. So in order to get to get n by itself, I'm going to subtract 8. So I have negative n equals 13 minus 8, which is, 13 minus 8 is 5. And then I'm going to divide by negative 1, and n equals negative 5. Now there is another way that you could solve this problem. I'm the type of person who often forgets to divide by negatives. So this is another way that I would solve this equation. I'm just going to move to another screen. I've got 8 minus n equals 13. So if I had 8 minus n equals 13, I would actually move my variable. So I would move n to the other side, and I would subtract my 13. So 8 minus 13 is negative 5. My n's have canceled out, and I'm left with a positive n on this side. So that's just because I have a tendency to forget to divide by that negative 1. Again, there's more than one way to do these questions. As long as your math is correct, I'm good with it. So let's take a look at another example, and this is using like terms. So when you see like terms, it's important that you simplify your question or simplify your equation before you start solving for x. So 7x minus 3x, these are like terms. And so 7x minus 3x is 4x. So 4x plus 19 equals negative 1. Now I can see I've just got a two-step problem. Again, thinking ahead to what math I'm going to be doing, I need to get rid of the 19 first because that's furthest from the x on that side of the equation. I'm going to subtract 19, and then I'm going to divide by 4. Again, if you can start visualizing the math, it's going to make it a lot easier as you go. So 4x equals negative 20, divide by 4, and we get x equals negative 5. I have 3 plus 4x equals 9x minus 12. When my variables are on opposite sides of the equation, I need to get them together on the same side of the equation. Again, I don't like dealing with negative variables, so I'm going to move my 4x from the left side to the right side because 9 is bigger than 4. You can do your steps together at once, or you can do them individually. I'll do them both here. So if I do them in one step, I'm going to subtract my 4x, and then I'm going to add the 12 because I want my numbers on one side and my variables on the other. And so by doing it in one step, sometimes using two different colors might help, but in doing it in one step, I have less writing that I have to do. 3 plus 12 is 15. 9x minus 4x is 5x, and then I can divide by 5, and I have x equals 3. If you choose to do it in individual steps, that's fine too. We would have 3 plus 4. So if I just moved the 4x first, I would have 3 equals 5x minus 12. Then I would add my 12, and I'd have 15x equals 5x, 15 equals 5x. And I'd be back to the same answer, x equals 3. So whether you do it in one step or two steps doesn't matter, again, as long as the math is accurate. Okay, so I'm going to look at the next ones here. Again, I'm just creating an extra screen so I have more space. If I have 5 times 2x plus 3 equals 10, the first thing I want to do is distribute through the brackets. So I'm going to have 5 times 2x is 10x plus 15 equals 10. At this point, I want to isolate the variable. I want to get x by itself. So I'm going to subtract 15 from both sides. And that gives me 10x equals negative 5. Divide by 10. And x equals negative 1/2. Take an opportunity to pause the video, try the next example on your own, and then come back and check to see if you're accurate. All right, let's check your work. We've got 7x minus 3 times 4x plus 8 equals 11. So your first step is to distribute through the brackets. So we're going to have 7x minus 12x minus 24 equals 11. 7x minus 12x is negative 5x. So again, these are like terms. So negative 5x minus 24 equals 11. Again, you could skip the step and add the 24 at the same time. I chose to do this in separate steps. I want to get negative 5x by itself, so I'm going to add 24 to both sides. So negative 5x equals 35. Divide by negative 5, and x equals negative 7. All right, so those are the types of questions that you're going to see. If you have any questions, go back first, watch the videos, follow the steps. If you still have questions, make sure during class time that you ask for help. The assignment has been posted, but again, you don't need to do the assignment until we're in class time, but feel free to work ahead if you're comfortable doing so. All right, have a great day, and we'll see you with the next lesson.